Okay, so we'll continue in this video number 6 from 2.7. We're still 2.7. This, of course, to practice a little more on the same idea. So we have a curve that's 6x squared minus x cubed. Now we ask the question differently. F prime of 1, which means derivative at 1, and use it to find the equation of tangent line at the curve at the 0.15. So now we just go ahead and use the definition, and now it's f of 1, right? 1 plus h minus f of 1 all over h, which will take 1 plus h squared minus, so we'll use the function 1 plus h cubed minus for f of 1. F of 1 is 6, 1 squared minus 1, just to show. So probably you want to pause the video and try it and then compare it with what I'm going to have here and see, because these now, there is many steps to do, and you compare and you see, and that's how you correct if there is a mistake. If there isn't, then it's great, and if something is not clear on my side, you let me know as well. So let's just work on this numerator part. So we will do this is 1 plus 2h plus h squared. This other one, you can try it maybe like, it depends how you want to do. You can try it something like this if you want to. And 6 minus 1 is a 5. So if you try it with this part, you're going to have 1 plus 2h plus h squared. Then 1 will be multiplied by that, right? So you're going to have it, as I mentioned, pause the video, try it and see if you get, and then you get h times 1 plus 2h plus h cubed h squared, so you get 1 plus 3h plus 3h squared plus h cubed. There is also some binomial formula you can use, but you can try it just that way. So 6 plus 12h plus h squared. Now distribute negative. All right, so the 5 12h and 3h, so 9h, and h, this is a 6, a 6 and a 3 gives us a 3, and minus h cubed. So remember, this is numerator, so if you to divide it by h, you'll get 9 plus, this is a square, because it's 6x squared minus 3h squared, and minus h squared. All right, so now we can go back to the limit, and we say what we found is this, and with that direct substitution, it's going to be 9. And so f of prime is for 1 is 9, which means if you want the equation with the point you're given, y1, 9 goes in the slope place and x minus 1. All right, and if you want to use the point slope or the other form is okay. Okay, so I was gonna do this number 10 from the same 2.7. Then I realized it's just same, it's even less than what we have been doing. And try it, and if you have questions, let me know. But this is just, you know, a pure slope thing, 1998 to 2004, 1998 to 2004. So this is like a data set. So if you want to find the average, right, the average value there, then you'll do just like 0.2 and 0.1, which means the value of the n at 2004, which is 182, minus the value at 69, divided by 2004 minus 1998. Then you do that again for 2002, 2004, and you do it for the third year. Then it asks you to get the two close ones and average them. So this is a technique that's going to be helping you to do some homework problems. And I think you can also apply it to a previous homework problem in which you have to find some tangent, right? So try it, and I think it's giving you the method to use here, right? So you find for this one, you find for this one, and you find for this one. Then estimate the instantaneous rate of growth by taking the average of the two, the 2 and 3, and ask yourself why 2 and 3, right? So the first I here, the first one, 1998 to 2004, right? So they're far apart, but this one is 2002 to 2004, and the other is 2000 to 2002. So these are close to each other. That's why we take the average of the other averages that we have that are next to each other. That's another way to estimate this. And, you know, and the average there is just the two values, and that's it. So you should be getting for I just did it on calculator, and you should get for I about 18.8 million funds per year. And for the second one, you should be getting 2.5. And for the third one, you should be getting 16, right? And you'll average these two to find the other answer. All right. So it's not a problem. I won't talk about these two problems here because they're similar, but they're not exactly the same. And there is kind of a takeaway or knowledge that we need to get. So before I work on it, I want you to look at the difference between the two. And this one is x, the function, this part, sine function 8 over x if x is not 0, and it equal to 0 if x equals 0. It's almost same thing. It doesn't matter, you know, the 8 or 5 there, but it is defined in the same way. But here, the difference here is x, and in this one is, I mean, that one is x squared, and this one is x. So if we look at this function here, and we set up the limit, because we want to determine whether this exists or not. So we set up as we've been doing in this examples. Then the first point here is 0 plus h minus f of 0 over h. So the limit as h approaches 0, and now it's you use, which is just h. So you see this 0 plus h, just h. So now we put that there, h sine of 8 over h. And when f of 0, when f0 is just 0 over h, so the limit h equals 0, and this cancels and gives us this. And I talked in the other video that we should know as a common thing, as h goes to 0, what happens? The sine function keeps bouncing between -1 and 1, so the limit here does not exist. Why? Because the sine function keeps bouncing between 1 and -1. So it doesn't commit whether h is approaching infinity or h approaching 0 or h approaching 1, you know, but here we're interested in h approaching 0, getting small. The sine function is still going to be bouncing between the two. And of course, any interval that is containing this 0. Yeah. All right. So for any interval having 0, the sine function bounces between -1 and 1, so it doesn't commit, and therefore the limit is not. Here, let's see here what happens. Of course, the x squared is going to change the story. So we're going to set up the same thing, define this. Similarly, now it's just h squared sine over 2 over h minus 0 over h, and now we're left with 1h. Let's write the limit h to 0, and let's just simplify h with h, and we get h sine over h. And if you look at previous homework, when you try to find this type of limit, you know, we use the squeeze theorem on it, and we're going to do that similarly here, because we know that sine of 2 over h, we just mentioned, is between -1 and 1. As h approaches 0, it could approach it from left or right or whatever, so it doesn't tell us much about h. So we want to make sure when we multiply this inequality here, we have to multiply it by a positive value, which means let's use the absolute value of h as a way of saying, hey, this inequality is not going to reverse, and so -1 times h and 1 times h absolute value. So let's just look at it that way for a second. Then, well, you know, you see that it doesn't matter, but technically we have to do it that way, so we're not, you know, reversing these, or we have to deal with both cases. But here, since the limit as h approaches 0, even the absolute value is going to be 0, right? And this part here is also, this we don't know yet, is this part here is also going to be 0. So by the squeeze theorem, the squeeze theorem, this f prime of 0 is going to be 0, right? and maybe I should just do it here since we don't have space. And since the limit is approaching h is approaching 0, you know, the absolute value is gonna, and h doesn't matter there, and the quantity there is going to be 0 because it is between 0 and 0 by the squeeze theorem. Cool, thank you.